I always hesitate to hit that button that says join with video, and it's like, I don't know.
Can you see me now? Okay.
Yes, there you are.
Okay. I clicked on this other one. This other one, I don't know how to get rid of it, and I'm afraid to even try.
We just ought to leave it there until we're done. So
yeah, and I hear an echo in it too.
Yeah, it's probably one instance feeding back to the other instance. It's even worse if you join once by computer and once by cell phone, just for redundancy, and then they get all messed up.
Larry McIntyre, are you on yet?
He is.
All right, Steve, I guess if anytime you're ready to start, I think we should be rolling here.
Great, great. The wonders of technology. It's like simple things are never simple. And I don't understand why, I never will, I don't think. Welcome everybody to the July meeting of the Early Television Museum community. Got a good program tonight. Let's start with Dave's usual courtesy announcement.
Yeah, I'll just remind everybody to please keep your microphones muted unless you're actively involved in asking a question. And I think our presenters tonight are aggressively inviting questions, but please keep your microphone off at all other times, and that'll help us keep the chaos to a minimum. Thanks.
Thanks, Dave. Want to thank the New Jersey Antique Radio Club for providing, sponsoring this meeting and providing our Zoom feed. We really appreciate it. Give you a quick report on the museum. We have 172 total members now, of which 141 are annual members, 25 are sustaining members, and that's a growing number, by the way, and we have 8 lifetime members, people who have made substantial donations to the museum. Our sweepstakes, as most of you know, are ongoing. They started a little while ago. The grand prize is a RCA TRK5. The cabinet has been restored and the electronics are all original and just ready for somebody to restore. That's pretty easy set to restore. Fortunately, the picture tube is a 5BP4, which is easy to find, though it comes, the set in the sweepstakes comes with a good one. We need to sell $8,000 worth of tickets in order to award the prize. We're at about 4,900 right now. I'm confident we'll reach that number because it's quite a ways till the drawing. Drawing is going to be October 14th at our fall swap meet. A little warning, I'll keep reminding people that the rules have changed, and we can no longer sell tickets right up to the date of the drawing. So ticket sales will stop a week before the actual drawing. So we'll remind everybody of that. So if you haven't bought tickets, buy them now. It's right. There's a link right on the homepage of our website. Any questions about what's going on with the museum?
Steve.
Yeah.
We actually had someone who came in today. They were from out of town and they actually joined. So you can actually add one more number to that membership.
Good. Glad to hear it.
I'll be sending you the information tomorrow.
Thank you. I should mention one more thing. Some of you may have seen this, but I was interviewed by a Associated Press writer a few weeks ago, and he wrote a nice story about the museum. It got published all over the country. We've gotten copies of the the articles from various papers, including the Washington Post and a bunch of smaller papers. And since that time, we've had quite a bit of an increase in activity at the museum, with people calling us, and attendance is up and so forth. So that's a great bit of publicity. All right, well, let's move on to our featured item tonight, and which is the Dumont 180 pre-war set. If you could hook Larry in, Dave. Here we go. This is a set we have on display at the museum out of its cabinet. And we've done this to show you what a monstrosity it is. This set was introduced in 1938. Apparently, Dumont went to England in 1936 and brought back with him a Cosser set that was introduced in 1936. We have one, and 137T is the model, and the sets are very similar. So I think Dumont just copied a lot of the circuits. The 180, which is the model we have, and the 183 are 14-inch screens. Now this is a big screen for a. There's the 180, and the 183 is the console model. 14 inches is a big screen size for a pre-war set. They actually made another set, the model 195, that has a 20-inch tube. And I don't know if any of those sets survive, but the 20-inch the 20-inch version used the same technology as the 14-inch. The interesting thing about the CRT here, other than its size, is that it's electrostatic deflection. And if you look at the neck of it, you can see, I think Larry can show you, you can see the deflection plates, some of them in there. Now, one of the problems with electrostatic deflection on a tube this size is that the anode voltage on the tube is 8,000 volts. I'll talk a little bit more about that a little later. And so in order to deflect the beam, you needed a very, very high voltage swing. And that was pretty hard to accomplish. I think the sawtooth wave on the deflection plates is almost 2,000 volts peak to peak in the horizontal and vertical directions. That's some of the, but they managed to get it to work. An interesting thing about this tube, another interesting thing, is that they had two versions of the set. The earlier ones were the model 180 and 183. Later, probably in 1940, they introduced the X versions. And the sets are pretty well identical, except that they generated both 8,000 volts positive and 8,000 volts negative. And so they were able to supply essentially have the CRT with an effective voltage of 16,000 volts on the CRT, which provided a pretty bright picture. And this set worked. We rebuilt it, and last year or so it died. But it really has a nice bright picture. Very, very surprisingly. Any questions about this set?
What frequency band did it operate in?
This was essentially, I think the tuner, it had I believe a 3-channel tuner. So it was a super heterodyne design, which is different from the Cosser they copied. It had the Cosser set only had 1 channel because Britain only had 1 channel, and it was about 45 megahertz was the video carrier. Here, the tuner in this set works from about 40 to 80 megahertz, and you could tune it to any 6 megahertz channel you wanted in that area.
I have a question.
Any idea of how many were built?
I have a question, please.
Go ahead.
Did it use AM modulation for the audio?
Yes. All of the pre-war sets, American sets, originally had AM audio.
Okay. So this thing, does it work now?
Well, it did up until last year when something died in it. But to anticipate your question, it is you can use a set with AM sound that is designed for AM sound with an FM signal source using slope detection. You just slightly detune the frequency of the audio channel, and the slope of that, because you're not right on center of the frequency, the slope of the response provides demodulation. And so the sound you can use this set even on NTSC signals.
Didn't these sets use a post-deflection acceleration? I see a side connection there to the CRT.
Yes.
So they get pretty good brightness.
It was pretty good, yes. Yeah.
Hey, Steve.
I assume it wasn't 525 lines. What was it, 430 or something like that?
Well, again, no, it was can't remember, 441, I think, something like that. They changed it all over the place during that time period. They ended up on 525. But again, the horizontal and vertical frequencies are the same, 60 hertz. And the horizontal scan frequencies for 525 is about 15 kilohertz. And for what they use is about 11 kilohertz. And the horizontal controls on all these pre-war sets will operate fine at you can just turn them right up to work with NTSC signals.
Who provided the NTSC signals for reception for this set?
Yeah.
Hey, Steve.
Yeah.
I think I've got you look here, I've got that tube, I think. Has that what I call an English socket on it. Does this look like it? And it's got that anode post on the side of it.
I couldn't hear you. Could you try again?
Sorry. I think I've got one of those CRTs for that set.
Oh, good. They are.
Can you see it? Has anybody seen the picture?
Are you showing it now?
I am. I've got a problem here. I've got to. I'm up on there twice. I thought I was having trouble with my computer, and I don't know how to get rid of this other one. And let me try this.
I kicked you out, Julian, one of you.
You're muted, Julian.
Can you hear me now?
I can see you in a little small. I can't see you. Your picture is on the screen, but just the thumbnail.
Oh.
Yeah, that looks. Well, wait a minute. That could be it. It's hard to tell. Does it have a number on it?
No. I did understand that it was a hand-built tube from pre-war, and it has what I call an English socket on the back, that huge socket on it, but you can see the anode stud there on it, maybe.
Could
Looks to
be.
be like a 14-inch or something like that. I'd have to measure.
It's probably the same tube. They made actually made a post-war version of that tube, which is as far as I can tell, pretty much identical, just has a different part number.
This one, yeah, it's got a huge neck on the back of it,
Right.
and it's electrostatic, of course. I imagine it would be. I don't think this one was ever used, but I'm not
Right.
sure about that. And I've got another one that's identical to this one, except it doesn't have that English socket on the back. It looks like a 21-inch round color tube would have on the back of it. And it does have a number on it. Let me go dig it up and see what it says. Yeah.
I have a
Well,
question.
go ahead.
Yeah, so the set is shown, even though inoperable, you mentioned it was compatible or would be compatible with NTSC broadcasts. So if you had the right converter from current digital to NTSC, would that set actually receive real and decipherable TV broadcasts?
Yes, several of our pre-war sets do work, and they do display. They work from NTSC, and they display, good pictures.
Wow. Thank you. So you could watch Howdy Doody on that rerun.
You could.
Okay,
Right.
thanks. Bye.
Question.
Hey, Steve,
Yes.
as luck would have it, I have the console version, and it had a bad CRT in it, and you could tell something was on, but it was very dim. And then a few years ago, Harry Poster had an article or an ad in eBay that he had a bunch of surplus stuff from a deceased Dumont engineer, and one of the tubes looked like it could be that tube, and I bought it. It had a lot of things this guy was working on, including helium neon laser tubes, and took a chance and put it in the set. I could see visually that all the pins seemed to be the same. And sure enough, I have a very nice bright picture with a CRT that probably only has a few hours on it now.
You're very lucky.
Yep.
Steve, I've got this other tube here. It has a joint Army Navy number on it. It's got a socket on it, like an old round tube color set, and it's a 12 GP7. That would be some kind of a radar. The P7.
That's a radar tube.
It's a radar tube.
As you probably know, Dumont manufactured all kinds of CRTs before, during, and after the war. So I suspect they made, they made that for the military.
Yeah, this one's the military version of it with a P7 phosphor in it.
Right.
If I may again.
Yes.
Okay, so we've established that set, if running, would be able to receive TV broadcast. NTSC is fine. But my question would be, the phosphor in that picture tube, CRT, whatever, would that actually look like a TV that was made in like 1953 in terms of the black and white that it showed?
Very simple.
Greenish or what?
It was a little, no, it was a little bit, we have a comparison because our one of our sets that works has has the original 12 AP4 tube, and we also had a bunch of British radar tubes rebuilt years ago to make replicas to replace them, and we have had both tubes, both the original tubes and the replica in that set, and there is a little difference. I would say that the pre-war tubes are a little bit muddier looking than modern, but awfully similar.
When you say muddy, do you mean in terms of the black color?
The contrast isn't as
contrast. Yeah. Okay. Okay. Thank you. Bye.
Yeah, it's a question. Do you have any audio on me?
Yes.
Excuse me.
There, we can hear you.
Yeah.
Yeah, earlier, I think you showed on a placard on the wall indicating it was a 14-inch set, but I believe when you zoomed the camera in on kind of an aged, probably thermally discolored label on the neck of the tube, I could swear it said 12-inch. So again, just to be clear, what size? What is this Dumont set?
It's a 14-inch. And the tube is a 14 AP4.
Excellent. Thank you very much.
Okay.
I'm gonna pipe up again. When the NTSC thing was what, 525 or whatever lines, okay? And so this set being pre-war, if you did watch a modern broadcast through the converter or original NTSC, did it have 525 lines, or did it somehow compromise resolution to accommodate the set's native resolution?
No, it had the bandpass of the IF in the pre-war sets was pretty similar to what was after the war.
Okay.
And so it displayed 525 lines with about the same resolution as a early post-war set.
Wow. It just muddied it a little bit, apparently. Sorry.
But the picture is awfully good on
Really is.
some of those pre-war sets.
Wow. Did it use a sawtooth for the whatever direction?
Yes.
It did. Okay, thank you. Steve, I've also got two more of these smaller tubes that have this English socket on the back. Looks like about a 3-inch screen on the front. And both of them have a tag on it. It just says type VCR 138A, British, from A&M Stocks or something. And it's dated April 23rd of 1947. And looks like it's about 15 inches or so long. Does anybody know what this might have been used in?
Well, it wasn't used in any of the British pre-war sets. I can tell you that, because they didn't. There were some 5-inch sets, but no 3-inch ones.
Well, this one could be. Let's see, 1, 2, 3. Well, it looks like a 3.5 inch or something, and it's about 15 inches long.
Typically, the 3-inch tubes are used on oscilloscopes.
Okay, even with that big English socket on the back?
That I don't know.
It's got the same socket that pre-war set has on it. It's definitely English. Not sure where I got these, but
it may have been a military tube of some, you know. You never know.
Probably was.
Yeah. Any other questions? Well, before we turn this over to our presenters, wondering if there are any newcomers to this meeting that would like to introduce themselves and tell us a little bit about yourselves.
I don't know if I'm a newcomer. I could be an old comer at my age.
Okay.
Sorry. Well, okay. I worked as a research engineer for many years until I became an artifact of retirement. I'm fascinated by early broadcasting in all forms, both detection, coherers, and all that in the AM radio sense, the development of FM. But as I almost grew up, I like to think, I watched a 1953 Emerson, I think it was. And so I'm very curious about how the electronics and so on worked in early television. That was really a nascent revolution that was going to come post-war. So here I am, I mean, I did digital circuitry professionally,
And so I'm not an analog person. My wife might call me that, but I'm not. And so I'm very curious how this early stuff developed. That museum somehow fascinates me. I mean, you guys really know what you're doing. And I even had, what was it, a CT 100 color TV in high school. It burned out and it got dumped, but that color was incredible. So for example, the phosphor apparently in that picture tube in that thing phosphors were very accurate. And so I was at some engineering conference and there was a display conference concurrently, and some guy actually had a converged CT 100 and compared that to a modern display, and the color was just incredible. And so that sort of fascinates me, how accurately early electronics actually worked, even though with 30 tubes it didn't last long. So that's, what can I say? Bye.
Thank you. Welcome. Glad to have you here. Anyone else? Well, I guess not. I guess we're all old timers. Excuse me. Did I hear somebody?
Steve, I've raised my hand. I'm not sure if you see that.
Oh, now I see it. Yep. Right.
Because I use the Zoom a lot. You know, this is sort of the habit I get into. Permission to introduce myself.
Go right ahead.
So I'm the guy with a cap. And I'm the new member that Larry mentioned, your person that was at the museum today. So I came in with another colleague, and actually my sweetheart. We both teach at this point in our lives. I teach as a result of retiring. I worked in the automobile industry for a long time, and then when I took retirement, the colleges love people like me, so they hired me to teach tech. So I'm a tech teacher. I'm from the Detroit area, and I was absolutely. My partner suggested, "Hey, let's go to that early television museum." I'm like, okay, not really expecting much, but we wound up spending like pretty much 4 hours. This is marvelous. I can't even begin to communicate to you how marvelous it is, because a lot of the years now that I've been at the college teaching electronics and communication arts, I call it the flat earth, which is the book has a picture of what you all have physically in this museum. When I was trying to teach display technology and all that kind of stuff, and so to see it in the flesh, to actually see these properties, was just rewarding as heck. I'm now when I go back, I'm gonna see if I can write a grant, see if I can get a school bus and drag everybody down from Detroit to go see your museum, because it's incredible to have that much artifact in one place. Is just I can only commend you all, and so that's why I wanted to join and probably participate in some other ways as well. So that's it. That's all I'll say for now. All right.
Well, thank you very much. I'm glad you enjoyed it. Anybody else want to introduce themselves? Well, I hear silence. So let's move on to our presentation. George Lemaster and John Turner are going to talk about quad videotape recording. And this should be fascinating. So let me turn it over to them.
And George, before you start, could you just take maybe 30 seconds for an elevator speech and just tell us who you are and what your background is?
Sure. My name is George Lemaster. I got into television working at a summer job at a TV station for vacation relief, and that led to one thing and another of working in broadcasting for several years. I did work on these 2-inch quad tape machines for quite a few years, and don't claim to be an expert on them, but Dave wanted to discuss them. So I did a presentation here, and I hope it'll be interesting. What I'd like to do is make it a very informal presentation. And if you have any question, please don't hesitate to jump in and ask, and I'll do my very best to address it. John Turner will show you later some very real machines in operation at his facility that I think will be just fantastic. What I'd like to do is go through kind of the history of how videotape recording came to be and what evolved into what we knew as quad. Quad meaning it's just a recorder that used 4 heads on a wheel, and as opposed to longitudinal recording like an audio tape recorder or something like that. And so I'll try to go through that. And again, please don't hesitate to jump in and ask questions. I don't claim to be the world expert. I just put down some things, and I hope I can touch on a couple of areas of how they record this on the tape, what some of the issues were, who the big players were, and how they got color to work on these machines, which was a pretty interesting history. So I'll try to head out here. Let's see, Ed, can you see that full screen on your present? You got it?
Nope,
okay.
Not yet.
All right.
Worked great in the rehearsal, right?
Yeah, working great. Always works in rehearsal. Can you make it do full screen there, or pull up that screen, Dave?
I cannot. You've got to make your PowerPoint the active screen, and then go back and hit the share screen button.
Okay. Well, okay. There it is.
No.
But
you got to go back
I'm
to
not
the Zoom
seeing
screen. Every time, every presentation.
Every time. Yeah, it never fails. Okay, I'm going to hit
George?
share screen. Yes,
I'm
sir.
sorry. If you give us permission to allow us to share your screen, we can search for this and place it up in front if it's necessary.
Does that do it? I selected it and I hit share screen. I'd be glad to do that. Share.
There we go. Now it's coming in.
Got it. Okay, and now I'll go to full screen. You still got it?
There yet? Not now. It is. Yep.
Got it.
Success.
Okay, here we go. The first thing on trying to record video, you got to have a very narrow head gap. As you know, with audio recording, you can run the head gap narrow and you can run the tape faster and get wider bandwidth on the recording. So there were some recording efforts before what we call quad tape. People would like to do this. One of the people that really wanted it was Bing Crosby, and he had a company called Bing Crosby Enterprises, and a man named Jack Mullen, who had been really a big figure in audio recording, was put on the job to try to come up with a video recorder for the audio recorder he had built for Crosby originally. And so he had some success. He used a multi-track head stacked vertically, ran the tape at 120 inches per second, did kind of a time sample. So he was effectively scanning the tape, but with a fixed head stack instead of a rotary head. And he did get it to work. But then in 1955, Ampex invited him up to take a look at what they had done. He came back to his company and sold it because he said they win. They understand how to do it. We don't have it. So he sold his company to 3M and then worked for 3M till his retirements. In England in the early 50s, the BBC had a longitudinal machine for 405 line called the Vera machine. It was band split. They had a high frequency and low frequency track plus sound. It ran at 200 inches per second. RCA was working on it as well, and they demonstrated in 53. They had a multi-track machine that recorded red, blue, green, mixed highs, audio, control track, a bunch of things on a tape going at 360 inches per second. And it did work, but it was a little impractical because of the tape speed. And I'll bring up another person that was important in recording history, and that was Marvin Camrus at Armor Research in Chicago. I know he worked on wideband tape. I don't see any evidence that he really worked on the quad machine, but he is an important person. in the world of recording. So in the upper left, there's the Vera machine in England, and the right is RCA with Sarnoff holding up the tape. Lower left is Marvin in Chicago, and lower right is Jack Mullen there on the left in the white shirt, and you recognize Bing Crosby. So Ampex was working on this, and they had been working on FM to try to make wideband instrumentation recorders for military and things like that. And they had been studying FM recording on tape. And so that turned out to be the really big breakthrough to put video onto tape. So they record FM RF onto the tape, not audio like you think of in an audio recorder. And the second problem they had to solve was that head to tape speed. So they wound up using a rotary head. They really were innovative in coming up with that. It also depended on having a really good tape that 3M came up with. And Bobby Ellerby has a really good account of that whole thing on his website, if you want to look there. And he has links to a lot of things that have tremendous in-depth history that we won't go into tonight. But in any event, Ampex demonstrated that tape machine at 1956 at NAB. This was the team that developed it. I think most of these people are no longer with us, but that was an amazing project. They came up with this machine, and it got really good results out of it with their innovative work. This was the production model of the VR1000 that they were selling in 1957. It's got two racks of tubes. You can see to the left, that's where the servos and the RF electronics are in. There's more electronics down in the base of the cabinet. You'll see an oscilloscope on the left-hand control panel, and then there's a Tektronix scope up in the top for looking at the video waveform. So that was a production machine. I don't know how many they sold, but quite a number of them. And they were taking orders as fast and building them as fast as they could after they showed it at NAB. So this recording head assembly had 4 heads that were mounted 90 degrees apart. The motor was locked to TV sync. It ran around. They ran ball bearings, and later they went to air bearings on the heads. The tape is pulled through at 15 inches per second. So a big reel of tape will run an hour, no problem. The thing they really won on was getting the video video head to tape speed up when they got 1,560 inches per second by spinning the tape vertically against the head, against the tape. And they were using a very narrow gap of about 5 to 10 thousandths of an 0.5 to 0.1 thousandths of an inch, very narrow gap. And it was quite a challenge to do that. They had to be very innovative on coming up with head materials that would withstand the pressure, the speed, the centrifugal force, and had the magnetic characteristics and the RF characteristics to lay that RF on the tape. So the heads passed RF up to about 7 megahertz, and they were using a wideband FM modulator and demodulator. And these machines had full response out to 4 megahertz, like you need for TV broadcast at the time. They used FM pre-emphasis and de-emphasis to get better signal noise, just like on any FM radio system that you know of. This was the head they used. This sharp eyes will see this is really an RCA head, but here's the head wheel. There's slip rings that connect it to the electronics. There's usually a preamp right behind this head wheel. Then at the top, the Ampex had a photocell. RCA used a little thing called a tone wheel so that they could know where head 1 was when it went around. This assembly over here is called the vacuum guide or the shoe. You can see a hose here. They have a vacuum pump hooked up to this thing, so it sucks the tape into that guide. And then this head right here is called the control track, and it lays down a 240 cycle tone to kind of like laying sprocket holes on the tape. Here's with the guide closed against the head, and the tape would lay in here, and we'll look at that a little more. When they put it in the machine, it goes sideways. The head wheel goes up against the tape. There's that vacuum guide I mentioned, control track head. The audio is recorded later down the tape. Down here, these are the audio heads. This is an RCA machine. It had a simulplay head on it, so you could check the audio. This was capstan, and then goes back. And again, this is running at 15 inches per second. The head wheel sideways looks like this. There's 4 heads 90 degrees apart, and then a vacuum guide to push the tape up against the head as it goes by. So as these heads go by, they're protruding out about 1 to 3 mils, 1 to 3 thousandths of an inch. And so as it goes around here, it actually is distorting the tape as it goes by in that guide. And there are a lot of adjustments you have to make that even if you just throw a tape on the machine to play it, you still have to be sure these things are right. Now, the manufacturer's job is to be sure these heads are 90 degrees apart. And in fact, when they started doing this, that was a really hard thing to control. And at one point, they would actually ship the whole head wheel panel with the tape to whoever was going to play the tape back so it would work. They didn't have a way of compensating. And then pretty soon they came up with RF delay lines. RCA had them, and then later other means to compensate. But keeping the heads exactly 90 degrees apart was critical for interchange between the machine that recorded it and another machine that you want to play it back. The other thing I'll mention is that as these heads are spinning against the tape at that high speed, they wear down. Initially, they were an alloy, I think. Most of them was called alphenol, but it's a metal pole tip. And so there was friction, tremendous friction, and they wear down. And so you'd put a new head on the machine, and these would protrude out about 2.5 to 3 mils. And then as you run the machine, they wear down. And when they got down to about 1 mil or less, it's time to change it. The interesting thing was the signal and noise would get a little better as the heads wore down, but then as they got really down, its noise would go back up, or you'd have other problems. They would just fail or something, or start clogging. Getting one of these heads rebuilt, head panels, went back to the factory. It cost in the 60s. I think it was around $1,500 to get one of these panels rebuilt. So after you run the machine, there's a cost per hour of running these machines. It was pretty steep. So broadcasters could do it, but it wasn't cheap to operate these things. There was a lot of maintenance. This is the way the tape tracks are laid down on the tape. This is the audio track up here. It was a big, nice, fat audio track. The electronics in the VR1000, I think, was identical to the Ampex 350 audio tape recorder. Down here is the control track. There's a sine wave recorded on there at 240 cycles, and then on field 1 during the vertical interval they would slam a big pulse on there, and that was put on the tape, and you would actually develop the tape with magnetic developer and find that mark, and that's where you would understand where to splice the next piece of tape so that you could go from one video frame to the next, kind of like splicing with the sprocket holes and the frame gap between the frames on 35 millimeter film. But that edit pulse was put on electronically to help you find where to splice these video tracks and slice across this tape. There's another small audio track in here called the Q audio, and that was just a low grade, like 5 kilohertz audio channel, not great signal and noise, but it was used to, you could put a microphone on the machine and talk into that track to find Q marks. Later, that was used for digital time code, things like that. In order to splice that tape, they made a splicer that would allow you to put the magnetic developer on the tape and then slice across it with a razor blade and look at this with a microscope. So you could find it. There's the can of tape developer and some aluminum tape that went on the back side of the tape to actually make a splice. Before very long, they had electronic ways of splicing these, so these became obsolete fairly quickly. But there were a lot of them, a lot of splices made with these mechanical splicers. When you're playing back the machine, these heads are spinning against the tape, so the RF comes on. There's about 16 lines of video recorded with every head pass, so they sequentially come off the tape as the head's spinning, and then there's circuitry in the machine to gate those pulses and multiplex them into one continuous FM output. And that was done by looking at where the tone wheel or where the position is on the head as it's spinning, and looking at separated sync off the tape to generate this switching in the machine to make one continuous output with those 4 heads. So there's a little overlap on them, but it had to they would switch during the during the horizontal blanking, sometimes right in the middle of horizontal blanking, and then the processing amplifier would replace the sync, so you didn't see the glitch. There were other ways they did it later on. As I mentioned, when you stuck a tape on one of these machines, you push play and you had to do a lot of adjustments. This is where I mentioned the tape has to go up into that guide, and it actually distorts the tape. as it's going across the tape. And so the tape has to be in and out, so it distorts that tape the same amount as it did when it was being recorded. Otherwise, you get these jag effects like this in the picture. This is if the penetration is less or more, the zigzags go one way or the other. Later, it wasn't very long before Ampex and RCA came up with an automatic servo that moved this head in and actually moved the guide in and out about 0.02 of an inch to compensate for this. So if you were playing a tape that had different recording penetrations on it, it would automatically correct while you're playing the tape. Excuse me. You also had to be sure the head was up and down in the guide properly. And also, if somebody had recorded the tape wrong, you had to compensate it. When you're making setting one of these machines up, Ampex and RCA made test tapes that were precision calibrated test tapes. They were not cheap, and you would put that on the machine and play it. And when you played the tape, you would compensate out these adjustments I'm mentioning here. And then once you got everything set, then you should be able to put a blank tape on the machine, record it, and it should then play back on somebody else's tape machine. That's always the name of the game with tape recorders, is being able to interchange tapes. As I mentioned, as these heads wear down, you have to keep compensating them electronically. The guide servo adjusts for this mechanical, but as the head wears down, its inductance changes. So the RF equalization circuits have to be readjusted periodically, maybe every 4 or 5 days, something like that. You'd check it. Particularly critical in color more than the black and white, but they all had equalization adjustments for each head that you would tweak. And also on the record currents, you would have make recordings. Once you got the mechanical set up, you'd make recordings and understand that the record current was correct. They put about 3 or 4 watts of RF into the head all at the same time to record as it's spinning against the tape and record. And you would have to make recordings where you would incrementally increase the record current a little bit at a time. Sometimes we'd talk into that microphone I mentioned for the Q track and say 1, 1.5, 2, 2.5, 3, and you need to watch the RF level off of those heads when you played the tape back and say, okay, well, it got up to saturation. We'll leave it at setting 3 on that one, and 2.5 on this one, and you'd set those record currents as you were optimizing the RF current on each head. So in 1956, Ampex had a really good black and white machine. They're selling them as fast as they can make them to the industry. So these were black and white machines. So NBC purchased a few machines. They had bought one and had it at the NBC lab in New York City. And the RCA Princeton engineers came and looked this thing over. And after running a lot of tests, they found that the RF system that Ampex had for black and white was fine, but it wasn't going to work for color. So they went back to Princeton and developed a few things that were really instrumental in the history of quad. Between January and August of '57, the Princeton lab developed an entirely new FM modulator and demodulator system to reduce the differential phase and gain. The reason, and the second thing they did is they reduced the FM deviation. We'll look at that in a second, because they had to get the differential phase and gain down, which was unacceptable for color originally. And then they found that FM had used a pretty wide deviation, which was a good choice at the time that they made, but it was just too wide to get good linearity for color. So they narrowed it to a much narrower deviation, down to about 1 megahertz, from about 3 megahertz down to 1. And that lower deviation got to be known as low band color. And later the SMPTE standardized the frequencies, but RCA pretty much nailed it in 1957. And then the next thing they had to do was to figure out a way to make the machine play color on color TVs. Everybody's color TV has this burst regenerator in it, and it has a fairly slow time constant. So with the tape jitter, they're constantly, the color would just appear totally unlocked on a TV set. So they had to build something that would stabilize the chroma, and they did. We'll talk about that a little more. So RCA demonstrates this VR1000 playing color to Ampex executives, and a lot of people, and then Ampex said, okay, we'll cross license you to build our machine. So RCA was in the quad tape machine as well. Incidentally, Ampex then incorporated that RCA modulator demodulator into their machines. RCA was selling color quad machines then in 1958. And also in 1958, NBC installed 8 VR1000s at Burbank for time zone delay that had to be put in place in 58. And so they could play back color shows time delayed. They would record a half hour at a time of the shows. They rewind one machine and be recording on another. So they bought 8 machines, and they had some additional RCA machines, and that was in Burbank. And those are, somebody just posted a thing on Eyes of a Generation. There's an RCA, I'm sorry, an IRE journal out there that details all that Burbank operation. But they had 10 machines operating, maybe 12 operating there in Burbank that were colorized using that RCA method. Here's the monochrome deviation. This is the FM deviation Ampex was using from about 4.3 to 6.8 megahertz. RCA narrowed it down to about 5.3 to 6.3. I'm sorry, 5.5 to 6.5 is what SMPTE came up with. RCA narrowed it down, and then SMPTE standardized it. So the point is they narrowed the deviation down, and that was called low band color. This was RCA's prototype machine they were working on. This was the production model, the TRT-1A they came out with in 1958. And then this is a TRT-1B that Jay Ballard and I restored up at the Museum of Broadcast Technology. It's shown here playing a black and white tape from, I don't know what year, but it's a low band monochrome tape. You can see the electronics for the RF are up here and down here. Down here's a more switching circuitry. Over in these 2 racks on the right are the servos, the power amplifiers, which are big 60-watt PA amplifiers that drive the motor and the capstan on the machine, power supplies, the guide servo, other things. So quite a few tapes. We have it hooked up to a couple of 30-amp breakers. You turn them on, wait about 5 minutes and push play, and it will come up and play. This was the color processor that RCA made. A lot of people confuse this with heterodyne color on a U-matic, but it wasn't that at all. All of the tape machines that were built from the beginning would record color. If you particularly if you had them set up for low band deviation, because this was called direct color. You're recording the entire NTSC signal up to 4 megahertz on the tape. But the problem is that when you try to play the tape back, the chroma is jittering due to just the perturbations on the tape and the servo not being that stable on the tape. So you had to have something to stabilize the chroma. So RCA did this with what's called a heterodyne processor. So they brought the video in, they split out the luminance here, 0 to 3 megahertz, and just passed it out. So the output of this thing is playing monochrome that's still got jitter in it, but we had to fix the color. So they filtered out the whole chroma bandpass from 3 to 4 megahertz, feed it through a couple of mixer stages, and they have a circuit down here. It's kind of like the burst regenerator in a color TV, but it corrects itself every horizontal burst. It sets a new stable regenerated 358 that they can mix in, and that's called the jittering 358. And then they have local 358 from your station sync generator comes in. They mix these together. So if the chroma starts to move one way on the vector scope, the other mixer moves it back the other way by the same amount. So within reason, this thing then takes chroma that has been stabilized in phase jitter, adds it back, and you get a composite color output. Ampex did a similar thing. They actually took an NTSC decoder, which takes quite a few tubes, like a color TV, and they built the same burst controlled oscillator like RCA did here, but then they demodulated the NTSC out into YIQ, and then they fed that into an NTSC encoder and came out with composite. So the net result was exactly the same as the RCA processor. Chrome is stable, monochrome's jittering, but you could watch it on a color set. I don't think Ampex sold very many. I don't know what the RCA one cost, but when the whole tape machine VR1000 from Ampex cost $45,000 list, the color mod cost $20,000. to go along with it. So I don't know if they sold a whole lot, but they had it, and RCA had it. RCA seems to have sold quite a few of these machines with color. This was the color chassis in the machine. It was a 6th rack to the 5 that you saw earlier to do that color. This was Ampex's color machine that they made with their decoder system. Before very long, transistors overtook the industry, and in '61, RCA introduced the TR-22, which was an all-solid-state machine, and they sold quite a few of those. Those are around. And so everybody's using this low band color that I talked about, but there was a problem. And the problem is that when you added, this is what RCA was fighting when they first tried to make the Ampex VR1000 play color. The bandwidth is narrow. The deviation of the frequency of the FM is very close to the color subcarrier. And the result was you get what they call moire patterns, a kind of a herringbone that you could see across color bars. And they're constrained on this because the head technology at the time would only let them go up to 7 megahertz, so they couldn't move it up too far. But Ampex continued research into FM system. I'm sure RCA was looking at it too. But Ampex came up with a very interesting innovation they called shelf working. And the idea was to move the frequency up, but how far do you have to move it up to get good results without killing yourself trying to make a very wide band head system? So they did what they found some sweet spots on moving the frequency of deviation up. What's causing this is that I'll show you just a second. It's due to interference in the bandpass itself. And they also added what they called a linear roll-off FM filter to help improve the signal and noise. So Ampex would find that by moving the center frequency of the deviation up, the products would get worse, and then they would fall, and then they would rise, and then they'd fall. So they kept moving it up, and they landed over here for the NTA system. They landed somewhere up here for 443 subcarrier PAL systems. But by doing this carrier shift of the FM up higher, they really were able to reduce that moire in the picture and make a really good looking color, signal, and noise. So this was the low band video I mentioned here from 5.5 to 6.5. They moved it from 7 to 10 megahertz. And to do that, they had to improve the head technology, revamp the RF systems. And but by doing that, now you've got room down here from the 7 megahertz down to 0 frequency for the sidebands. The problem is there are sidebands produced in the FM spectra when you do this FM deviation, and they get lobbed off here at 7 megahertz for that. But the lower sideband is where you put all that chroma information resides. But the trouble is, when you modulate this low band with 358, the sidebands reflect off 0 and come back, and it creates a lot of spurious mixing products in here that create that moire, and there's really no way to filter it out. The answer was what Ampex did was move it up in frequency. So they introduced in 1964 a machine called the VR2000 that implemented that high band technology, and it fixed the color problem. Now, keep in mind, both of the low band and the high band still record the same bandwidth of NTSC, but the problem was in the low band, you had these spurious products created by the color subcarrier in the FM spectra that were causing that signal and noise problem. So everybody jumps on the high band wagon. RCA implemented high band versions of their machines. There was a TR-22 high band. Ampex came out with a new machine in '66 called the VR1200, and they could put that 1200 electronics back in the old 1000s if you wanted to and high band them. RCA introduced a new high band VTR called the TR-70. There was a company in Palo Alto called Allen Electronics, and they were building solid state replacements to rebuild VR1000 tube machines, and they started building high band modifications for there. They were using recording heads made by Fernseh in Germany. Fernseh had a license to build quads machines, but they sold very few of them. But Visual was buying the heads from them, that would do high band, and they could rebuild a complete VR1000 to solid state and turn it into high band. And then they introduced their own machines as well. So in 1966, RCA came out with their answer to the Ampex 2000 called the TR-70. And then Alan had some machines. This was a VR1000 that was rebuilt to a solid state. So the tubes have been pulled out, and this is a transistorized machine, high band, that they sold. And then they also produced some higher end machines as well for high band. So that point, they through that time, you had the innovation of Ampex coming up with the recording. You had people making them in color. A lot of machines out there running videotape. They could, in general, interchange. You had a lot of stations would upgrade to high band as soon as they could because you got better quality. But also, if you were playing commercials or shows or making shows, you wanted to get the best quality, so they would upgrade as soon as they could. But that all costs money, so it took some years to transition from low band color to high band. If there's any questions or anything I can go over, I'd be glad to answer them. I know John Turner wants to show you some machines in operation, which will be fabulous, but anything I can answer right now.
Hey, George, I'm going to just suggest John's going to have to take a slight pause in the middle of his presentation. So why don't we use that time to for everybody make a note of your questions, and you can take questions while John's doing
that sounds fabulous. Let's do that. So turn it over to John.
Okay, you got your share screen on. You want to shut that off, or you want me to? There we go. Your microphone's off, George. And okay, John, are you there?
Yes, I am.
All right. Hey,
is there a way to?
If you'd be kind enough to tell us just a little bit about your background also, so everybody knows you.
Sure. Let me figure out how to unmute this. Okay, there we go. Yeah, I'm a graduate EE. I've been working with television since I was a little kid. My father and I built a television in 1947 from a kit. And I learned about high voltage and 6BG6s and 1B3s really early. I was about 4 years old. I got bit a few times. So anyway, that bug kind of stuck with me. Even though I went to a classic college for engineering, I spent most of my time growing up playing with this stuff. And after school, or actually before that, I started a system integration building in New Jersey, which is where I am right now. And we've had a pretty good run of it. So that's where I am today. So I'm in a building here in northern New Jersey that we built in 1990, 2000, and it's full of stuff. There's a lot of people would like me to get rid of it, but for now, it's here. So I'm in the lobby of my building, and I'll show you a couple of things before we move around and look at particular machines. So let me get this little camera here. All right, so starting over here, we won't do too much here, but I've got a collection of 1-inch machines, starting with a digital.
Can you
1-inch.
share your screen?
Oh, I don't know how to do that. Let's see. Tell me how to do that, guys.
You're good, John. Let me just make sure that you stay. Hang on, let me spotlight you there.
Oh, there we go. Excellent.
Okay.
All right, so I got a collection. These are 1-inch machines. Maybe someday in the future, Dave will have us do a 1-inch thing. I got probably 100 of these. There's a high def analog 1-inch machine that doesn't record anything digital. It's all analog. And there's an early Sony C format machine that RCA sold in the US, pretty much put Sony in business here. There's a digital 1-inch component machine. And now let me get around here to what I'm going to show you. I'm going to roll my portable card around. Hold on, please. Okay. I'm trying to move a wire. There we go. Okay. Well, this is where I need to have somebody give me a hand with this. Nancy, can you give me a hand?
I'm coming right
All
now.
right, just pull this out of,
Oh, I see. Okay, I got it.
thank you very much. Okay,
Are we going in the other room?
I'm gonna start here.
Go ahead. Hold on, hold on. Watch it, watch it. Okay, you got it.
All right, let's take a look at this. This is an RCA TR5. It's probably the first, I guess we won't call it portable, let's call it mobile quad recorder. It records, it doesn't play back. It's a low band mono machine, but as George mentioned, the tapes that this made, if they were recorded with color input, would probably play back on one of those later modified VTRs. But let's take a look at the head assembly. Now, this is what George had in his picture. One of the things I want to show you that I've always found interesting is, I don't know if you can see it, but on this shoe down here, somebody actually machined in an RCA. Where is it? They machined in an RCA meatball. I always found that to be fascinating. I have no idea why they did that. I mean, think about somebody trying to pay for that today. But anyway, this is the ball bearing head wheel. Here's the tone wheel in the back. This is the female guide for the tape. And this is a vacuum hose that pulls the tape into that concave shape. The four heads output to a set of brushes over here, and they're carbon brushes up against slip rings. And this was around for a while, but that tends to get very noisy after a while. So that got replaced with a rotary transformer. The audio's over here, and that's pretty much it for this guy. Doesn't require any compressed air. All the machines after this had to have a compressor either in it or in your house to drive it, and you needed about 50 pounds per square inch and about 1 to 2 static CFM to run these things. So that's that. The other interesting thing is this reel says for Lawrence Welk shows only. So I guess I know what that machine was for. Okay, so now we'll take a look. I'm all right. We'll take a look at this. This is the last machine that Ampex designed. I don't think it's the last one they sold, because their predecessor to this, the AVR2, lasted a lot longer in the market. This machine had a number of interesting features. I'm going to show you one in the back that's online, and we'll thread it and run it a little later when we go back to the shop. It doesn't play low band, and it doesn't play low band color. It's a high band color machine only. The electronics are down below. It's very easy to service. This pops out and there's all your boards. It's quite a nice piece of work. Another nice thing is there's no pinch roller on the capstan. It uses vacuum to pull the tape against it, and then it uses a tightly coupled servo system on the reel motors so that the tape is fed out and taken up depending on where the capstan is. So basically the drive mechanism and the shuttle mechanism only really operates on the capstan, and the reels just follow along. And that's a very interesting thing that they did. Now over here we have an RCA machine. This is the last model that RCA built, called a TR600A. This particular machine came out of a NBC TV station in New York State. It's got a lot of hours on it. It's high band color, but it will play low band. It has a spotty reputation because there's a lot of monostables inside this thing, and as anybody knows, when they get warm, they change. So that probably wasn't the best way to build timing circuits. All right, I think that's it for here. We're going to go in the other room now. Hang on.
Can help you? Hold on.
Yeah.
You can't push it
Okay.
over the wire. You're not doing it.
Oh, sorry.
All right, go ahead.
Okay, good. All right. So we can start over here. Here's an Ampex portable. This is a VR 3000. It's a high band machine. It will record high band or low band. It holds a 20-minute reel of 2-inch tape. The head is a Mark 11, which was a ball bearing head. I'll fire it up and let you listen to it. I'm not going to play any video of it, but I'll let you hear. The power is a battery, is a battery well here. You pull this AC supply out and drop a battery in. I think they were silver zinc, and they would run for about 25 minutes or so. This thing, let's see. There she goes. So the head does not need air, but it does need vacuum. So there's a pump inside. You might be able to hear that. These are pretty popular because when you push the stop button, it rewinds, and it does that so that it can make a clean insert or assemble edit at the point when you start recording again. All right, let me turn that off. All right, so RCA built one like this, but theirs was a 2-piece machine, and it was not something you could easily carry around with. You had to put on a cart. One of the things that Ampex did was they had an advertising piece which shows a cameraman with an aluminum rig on him, with this thing on his back and a camera on his chest. And I'd love to know what that guy had for breakfast. This thing weighs about, I can't hardly lift it. It weighs about 80 pounds with the battery in it. Amazing. All right. Let's go over and take a look over here. Okay, so here we have another RCA 600A. This particular machine is meant to work on the on American Power. It's a 60-cycle machine, but it only records and plays PAL and CCAM. So it will not work with NTSC. Then over here, this is an Ampex AVR2, and it's probably the most popular machine that Ampex ever made. It could be assembled in various ways. The mechanism on top here comes out. The side panels come off. This thing can be carried by 2 guys with these handles on the side, and then the processor down below plugs into the top with a couple of cable umbilicals. So these were really popular in mobile units when their power was available in place of the portable, because you can record a 2-hour reel or now a 90-minute reel of tape with this thing. Let's see, what else can I tell you about this? This particular one is a late machine. This came out of ABC, New York. This has an electronic tape counter in it. This was also a later development. The early machines were used a mechanical Vita root type counter, but this one is electronic. And that was actually worked to be part of an editing option for this machine, where you could record time code on the Q channel and then edit the tapes. All right, so I think that's what I want to show you out front. All right, Dave, can you take this back? And I'm going to roll this thing in the back.
All right, George, if you want to jump back in and if anybody has any questions for you, this would be a good time.
We have to unwire.
Okay.
What about
Yep.
This red wire. We have to unplug this?
No, just roll it over my head.
Oh, okay. This is gonna go all the way to.
Oh,
the
you
back?
know what? No, it isn't.
No, it isn't.
Hold on.
Hey,
I'll just
George.
unplug it over there and, because I'm gonna
Yes,
break
sir.
it, right?
Yep.
Hey, John,
Hey,
excuse me for a second. John Turner, I'm going to mute your microphone, so you're going to need to unmute yourself when you're back on.
Just did it here, so I can do it on the mic.
Okay.
George, did you ever know Bev Gooch?
No, I don't know him.
He and Eckhart Wilms worked at Ampex over there. and they were the ones that developed some of those recording heads. Of all the crazy things, Bev Gooch lives here in Knoxville, and he had quite a collection of stuff there and some stuff, and he told me, and we were talking about the heads on a quad machine. I thought, well, what's involved in repairing those things? And he said, no, he says, you don't understand. He said, it takes about $1 million worth of equipment to refurbish those heads. And there used to be about 3 manufacturers that used to do those, and then it went down to 2, and I think there's barely 1 now. And now when they have to transfer tapes, they charge like $300 a half hour to transfer quad tapes there, because those heads have a finite life of about 750 hours, plus or minus, depending on how you take care of them.
They used to only run between 100 and 300 hours. If you used to be, if you got 300 hours on one of those heads, you celebrated and broke out the champagne. But they didn't last very long back when they were metal. Once they started making ferrite heads and things, they last a lot longer. But in the 60s and early 70s, you changing heads and adjusting them all the time.
Is there still anybody around that's refurbishing those? I know they used to charge like $1,500 to do a head, and my last understanding, it's about $3,500 now.
I think it's more than that. Somebody online, I'm sure, knows.
As I understand it, Video Magnetics closed down and there's no one left. George, couple things. RCA had a radar recorder out on Quadralon that did the longitudinal at the whatever that super high speed was, record radar data, and that was kind of the same thing that they were doing with the longitudinal video. I did look up while we were talking. I found the price list for the rack for color for the TRT, $9,500 and 68.
Okay. Ampex was 19,500 in 1958.
Now that was on a price list that they were closing stuff out, but they said it was $9,800.
Got it.
The other thing is the portable machine that RCA was selling as the equivalent of a VR3000 was actually a military machine that was an octaplex, 8 tracks on the head. So it was used for military purposes. And I understand RCA had them on TR-70s or something like that did that. I don't know if the FR1000 by Ampex was that or not.
I don't know. There was a whole product line that RCA made. They looked like those quad machines, like the TR-70 and those, but they were data recorders, not video recorders. And there are actually on World Radio History, there's one of the issues of RCA Engineer on there has a whole big spread on it. They even made a TCR 100 cart machine that was a data recorder, not a video recorder. So yeah, there were various applications of using that rotary head with more than 4 heads and for non-video purposes, but for just high-speed data.
And Ray Dolby, I believe he was in high school when he was and came in to work on the VR1000 project. And Fred PF, however you pronounce it, I was told that he's still alive.
I was told he might join us tonight. I wish he would. We'd love to talk to him. Fred Fost.
Yeah, he was the machinist that did a lot of the machine work. I was very fortunate. I met Charlie Ginsberg, and Charlie Anderson was somebody that I met, and a wonderful man. I met him once when I was just starting in this. He remembered who I was. Whenever I saw him, he would greet you like you were the best friend, and he'd known you forever and ever, and you were a good person. And I even arranged to have him come into Detroit for a SMPTE presentation, and so a very good man. The other manufacturers, I know Ferenczi, that last picture that you showed of the Allen machine, the one on the right was a Ferenczi quad.
Well, it was a Ferenczi transport in an Allen machine.
Yeah, yeah, and but Shabaden, or however they did.
Yeah,
The Russians had one, and then there was supposedly there was a Hitachi or somebody had one that they did the slow-mo on quad, which was, I saw the paper on it and I couldn't believe how they could do it, but that was another company that supposedly did it. But the primary ones were Shabadan, Faransé, and the Russians outside of Ampex and RCA. And I consider the visual and the Merlin, etc., those were just modifications of other people's.
Well, they made their own electronics. I mean, Allen made their own servos. They made their own RF systems. All those solid state equipments in there. They did buy Amtech, ColorTech, and so forth from Ampex, which raised the cost of their machine for them to make them that way. At the very end, their machines used Shabadan time-based correction stuff, and they sold a few machines, but about the time high band was going, Visual Electronics themselves declared bankruptcy, and that shut down the whole Allen thing. But they had built a slow-mo machine. They had a small machine, kind of like the RCA TR5. They had that big machine they called the VA100 that used the Fernzey transport end head. They were using Fernzey high band heads initially because Fernzey had the first rotary transformer high band heads. And so those worked. And then when Visual went bankrupt, you couldn't get the Fernzey heads anymore. So you had to convert the machines over to the Ampex heads. And that required pulling the transport out of the machine, getting it remachined so it would fit the Ampex head and put everything back together again. So there were a number of them around. They were not as expensive as the Ampex and RCA machines, is why they were selling them.
Well, interesting, you mentioned TR5. I had one of them. It was an interesting machine, and you could put an air conversion kit on it too, by the way.
Yeah, even the TRT1 at MBT is plumbed for air. If we just run a ball bearing head on it instead of air, but it will take air as well.
And that machine's in good shape. The other thing is that Ampex had the VR1100E, which looked like it was the same style as a TR5. The transport was flat and the electronics were below it. And so it was basically a mobile thing recorder that you could have. No scopes, no nothing like that, but it was there. And so that was kind of an interesting thing. And I believe somebody told me that the 1100 from Ampex, they use servos and signal systems from the 8000, which they tried to do a helical 2-inch machine, and it bombed, shall we say. Okay.
George?
Yes, sir.
It's Mike Molnar. I was curious as to what the maintenance schedule was on these machines. How many hours of uptime until you had to actually tear it down and go through a lot of this stuff, and how long that took?
Well, I don't know.
That's a great question.
That's a great question. I never. I know people would take these machines, and there were AF Associates in New Jersey and Merlin out in California that would take machines and rebuild them. I guess I never worked any place that would do that. We always just did them piecemeal. Whatever would break on the machine, we'd change it. The main thing you had to keep swapping out was the head panels if they went bad. But then you had the normal things, the brakes, the motors and things like that. Most of them, held up for a long time. I don't remember ever changing real motors or anything like that. I suppose somebody might have had them go bad, but it was always, these machines were, every place I worked on them, they ran them almost 24 hours a day until they quit. And then once they quit, you would fix it, or, you'd do periodic maintenance of check those settings, like I mentioned, record currents and playback EQ to be sure that the operators had things in the middle of their range and stuff like that. But the machines I worked with, the RCAs and the Allens, they're pretty much hands off until something wasn't working, and then you just have to stop and fix them, find what was wrong, get them adjusted, up and go on, because they were money making machines, and you just had to keep them running as long as you could.
I had a maintenance schedule for the Ampex 1200s and the AVR 2s. Every 25 hours, basically, you would sit and do a head optimization so that you had good record and playback. And we did everything as tight as we could to an alignment tape, so you really didn't have to touch the heads after you did all that. The other thing was, I think it was every 100 hours, or if the 1200s would not lock up in less than 4 seconds, we'd be going through and doing a complete servo alignment. And we were hoping to get a 3-second lockup all the time on those. Most people were 5 seconds if they were lucky.
Well, you're right. They should lock up in 3 seconds. I've never dealt with, I don't know of many machines that won't lock up in 3 seconds if you take care of them at all. Set the tensions and that sort of thing. But and machines like a TR70C, those will lock up in a half a second to a second. AVR ones, of course, lock up instantly, but these are machines that don't have vacuum columns. John might jump in with what the AVR 3 does, but most of the old classic analog servo machines would, if they didn't lock, you're right, if they didn't lock up in 3 seconds, there was something wrong and you should take a look at them. Even when I worked at NBC, we had a room with about 10 CR70s and 2 TCRs. And again, they just ran them. I would work on them after hours on the night shift and do any mods or tweaks or anything like that. But they ran them, on the order of 20 hours a day or so. And again, we just ran them until something needed to be done. We would still periodically, when you adjust those head settings, like you mentioned, you can set them up, but then the next thing you know, an operator throws a tape on the machine that has been recorded badly, or on a machine that wasn't set up, and they mess up all the head adjustments. So about everybody has to know how to throw a tape on the machine and look at an alignment tape or good dub of an alignment tape and get it lined up. The only machines that you didn't have to is like a TCR 100 cart machine, and we didn't talk about those, but as long as people kept their hands off the guide height and stuff like that, they would stay put. But mostly people would have to tweak things or think they needed to tweak them in order to optimize the playback of a machine. And that would cause you to have to retweak it when you started making a good recording. You wanted to check it and be sure it was okay.
One of the things that we did in the editing, because we were doing editing, one machine was always the record machine and the others were the play. That record machine, before a session, you would check the guide heights against an alignment tape. We'd chop off 1 minute so that we wouldn't ruin the alignment tape and keep running it. And it was amazing. If you take and do that, anything you made on there, you put it on the other machine. If you hadn't touched it, it played perfectly. We were very much into making sure we met specifications, even to the point of sliding the edit pulse a little bit one side or the other so that it tracked exactly as an alignment tape did.
Yeah, that's another critical thing to set up. One other thing I didn't mention when I was talking about the head wheels as they wear down, when you can't fix this really, but when if you record a tape with a head that's brand new, let's say, and it's got 3 mils of projection, 2.5 mils, and then as that tape wears down, it's down to maybe 1.5 mils of projection on the head, and actually when it's doing that, now the head to tape speed is different. In other words, when you have a tape, it's recorded on a head that's got large normal protrusion at fully new head, and then you play it back on one that's got less tip projection, that means that the head to tape speed is different. And what happens is that is called velocity error, and there isn't anything you can adjust about that. In the old days, we would have to take a tape and try it. Maybe if you had a couple of machines in the place, you would try the tape that you're playing back on one machine or the other and see which one had the least error. And the way it manifested itself is there was a huge shift from the left to the right across the picture. And that was because the head's tape speed was different between the tape, the recorder and the playback. So Ampex came out with another $10,000 accessory, and RCA came out with an expensive accessory, but they fixed the problem. It would electronically compensate by sampling the burst at each end of the line and then developing a ramp function across the screen to tweak the subcarrier as the line played out from left to right across the screen and compensate for that velocity error. But that was another thing that was is something you couldn't adjust out. It was just a function of the headwear. Looks like John's back online here.
I would disagree with you, George, because the penetration of the head into the tape is, if it's consistent with the alignment tape, it doesn't matter. The velocity is going to be the same as it goes down the tape, I believe.
Okay.
But the velocity errors are height and of the guide and penetration errors from where it was recorded. Okay, I'm done.
George, in my collection of stuff, I've got a 2-inch tape machine, a small one. I think many of them were used in airlines where they would play movies, and it's like a linear tracking machine. Are you familiar with those?
That's a
Is that a
PB
Sony?
120. Yeah, it's a Sony.
Yeah,
120.
John can tell you all about those.
Yeah, there was a facility in Long Island called Video Flight, and I think Sony paid for it, and it had 60 PB 120s, which is a 2-inch helical scan machine. I have one here. And on each airplane, they had a VTR, the same machine. They were about 130 pounds. They would play a 1-hour tape, and they put 8-inch black and white televisions hanging from the overhead luggage bins every few rows. It was quite a mess, but it did the job until Barco came along with their loop cartridge film projectors. But yeah, that goes back to about 62. I worked on that when I was in college. Hey, Dave, can you unmute? Can you unmute me now?
No, were they color?
Oh, no.
You're on.
No. Oh, thank you. Yeah, I can't.
No, now you're muted again.
There we
We
go.
heard you before.
Yeah, those machines were not color. Helical color didn't come along until about 1970. And there was all kinds of tricks. We got to do 1-inch one of these days because I must have 100 of those things. Anyway, this is a VR 1000. It's the machine George talked about. It is the C version, which was the last, I guess, shop run of them. The electronics were in these 2 racks, which I just sent out, had them cleaned up and repainted because they were a mess. All the chassis are down here, and the machine's 100% vacuum tube. I may be a couple of diodes in it, but even in fact, I think the rectifiers are solid state. The driver tubes for the head and record were EL34s. So as George said, it took quite a bit of power, or they ran quite a bit of power into the heads when this machine was in record. So this is intact. I have all the parts. Again, time is my enemy here. I just haven't had time to get it back together again. But there's a few of these still around. I think the museum in Rhode Island has a B version, and I think they also have one that has been modified and has all the electronics in the overbridge. Okay, and it has the same head design as the RCA. It's got vacuum pump in the bottom. There's the same head arrangement and the ball bearing motor, and that's pretty much it. Those machines were pretty similar in a lot of ways. All right, let's go back over here a minute. This is another AVR2. This machine is in pretty good shape. It came from a TV station in Binghamton. Took a little work to get it running, but it makes really good pictures, and I can see why they were very popular with stations when they came out. Not just because of the portability, but the fact that the electronics were all digital. And this was one of the first machines where the video off the demodulator was converted to data and then run through a time-based corrector in the digital form. And they could do a number of things. They could do velocity correction in that domain too. All right, let's take a look further down here. And here's an RCA TR60. This is one of the last vertical machines that RCA built. They went from the TR3 and 4 to the TR50 to this one, and then one more called the 61, which came after this. This one came out of a chicken coop in Delmarva, and it was in pretty rough shape. It's pretty corroded on the inside, but it actually makes pretty good pictures. There's KVEC in it and a DOC. And those were, again, things that were added after a while to these machines. The early machines didn't have dropout correction and didn't have chroma amplitude correction. All right, let's go over and take a look at the AVR3 that's hooked up here. Give me a second. Okay, this is a late model Ampex AVR3. Again, the electronics for this are all in the works in the drawer. So that's that. One extender board allows you to fix them all, which was a nice design. All the power supply test ports are right here in the front. Again, these things were built by guys who knew you had to maintain them at a station. On the right side, we have all the electronics. The time-based correctors over here, and the playback and record controls are over here. All right. So what I have here is got a sync generator powering up the machine, and I got this monitor on the output. This monitor blew up this morning. It's a Tektronix 650, and they're well known for blowing up power supplies. So let's thread it up and run it very briefly. Okay, so put the camera back. All right, so down here on the floor, I've got a kick switch, which takes the brakes, turns the brakes off on the wheels, so they spin nice and smoothly. So what we'll do is bring the tape up. Some guys can do this with their eyes closed. And when this is set, we'll get some vacuum showing up in inches of mercury, inches of water on the gauge here. And on this machine, it wants to be set to about 35, so we can adjust that. This machine has a head wheel called an Ampex Mark 15. It was shared with the AVR2, which was a great thing. You can change, this thing says play, there's also a record setting. This changes the setting of the guide depth away from the tape. And then there's a control here which adjusts the penetration of a guide in this direction. There's another one that adjusts the in and out. And I'm going to show you what that looks like on a monitor. Okay, so this is set. Let's see if it works. Okay, and you probably heard the head wheel come up. It's running at 14,400 RPM. This is an air-bearing motor. I've got a house air system here. So I'm bringing air down from my upstairs compressor room. and it runs around the whole building, so I can put machines any place. So we'll leave that open for a minute, close the audio head, and we'll just pop it in play, and we'll see how long it takes for a picture to come up when it gets to a recorded part of the tape. Now, what we,
Your camera's pointing at the ceiling.
oh, sorry, guys. So obviously this head's a little dirty. And those artifacts you're looking at are very normal to quad machines. On the AVR one, a lot of that will be taken care of. I'm going to show you that last. Now, if I go over to this monitor, that's the demodulator output. And as you can see, the color isn't usable for anything. Also, if I misadjust this guide, you can see the change. That's what George was talking about earlier, where the guide has to be set to the same locations as it was when the tape was recorded. Okay. Now, after the electronics get busy, the output of the machine looks like that. This machine has a time code system in it, and it records SMPTE time code on the Q channel, which you can hear. What SMPTE code sounds like. Okay. So if I clean those heads, I can get rid of that mess that you're looking at on there. But I'll have to stop and unthread it. So anyway.
With many VHS units now having experience.
Now this particular machine has one very interesting feature, which is rare. The audio system on it is stereo. What they did was they took the standard audio head under here and they split it just like you do on an audio recorder where you're going to go from half track to quarter track. And at the, because the quality of the tape has gotten so much better than it was in 1956, and the electronics are very good. And there was also connectors on this machine to add Dolby A noise reduction if you wanted. So this machine could be used for stereo. In fact, I have a couple of tapes that are recorded with this particular stereo system. There were all kinds of other tricks. Some people tried to use the Q channel. Some people tried recording left plus right and left minus right. But I think this was the only one that actually was sold as a product. All right, so I think that's it for this. Let me move around to one more location. I'm going to show you one more machine. Let's stop this. Turn the head off. Okay, I'll be right with you.
Well, while you're moving, the time-based corrector in the AVR3 uses almost exactly the same boards as in an AVR2. And then the stereo audio, I think the first time it was stereo was somebody modified in an ACR25 at MTV to do that. But and it was vertical interval, I think. John Streets at Merlin, I think, did that. But anyway, we'll let you keep moving.
When I see you moving,
It's okay.
I'm all the way down the hall.
One more. All right, I need the power cord next.
Got it. Okay, that's a big one. Got it? Is it there?
We have an Ampex 1200 at the Texas Broadcast Museum that was modified by WTTW in Chicago for early stereo TV broadcasting. It has Innovonics recording amplifiers in it, and they had a special head made for it. Kind of an interesting piece.
Yeah, now that you mentioned, I remember them doing that.
Yep.
What
Well-
was the model number of that airline tape machine that I've got?
Might be a
You're talking about the,
CR-8 or
the
a
American Airlines?
CR-1500.
Okay, you got it. You all right now?
Yeah. That was called a PV 120. And they're quite rare now. I've got a 100, which was an earlier one in one of our shops, but I don't have a 120. I've been looking for one for years. Okay, this is the kind of the granddaddy of all quad machines. I think most people who worked in broadcasting would agree that the AVR1, which is what this is, was kind of the best of the breed. What made it the best of the breed was a lot of innovative things were done. First of all, in the signal system, the machine is automatic sensing. You can put a tape on it, and it doesn't matter how it was recorded. It'll figure it out and set itself. That's kind of cool. The other thing is, it'll play a tape without a control track. You just go over here and put the tracking into the 4-second pivot, and what it does is it jitters the RF envelope by jittering the head wheel phase, and then it measures that and it adjusts it until it peaks it. It's kind of the same principle that Ampex did in the AST design for their 1-inch machines. Now, the other things that are interesting is the time base corrector. So over here, in the bottom, this thing uses digitally switched delay lines. There's nothing digital about the video, which is one of the reasons why the machine looks so good. What they do is they put it on a 30 or 60 megahertz carrier, and they run it through delay lines, and then they switch them on and off in the vertical intervals. So there's delay lines for 32, 16, 8, and 4 microseconds, 2, 1 microsecond, and then there's a vernier for the color. So that was very innovative. Let me close this guy up. Okay. The next thing that's clever is the way the tape tensioning works. You'll notice that again, like the AVR3, there's no pinch roller here. Just a capstan that had vacuum on it. Let's open this guy up. Okay. So now, what they did in here, it had an array of light bulbs, and at the top they had an array of photo detectors. When you thread the tape up, it comes up into this chamber, and there's vacuum pumps down below which suck the tape in, and by measuring where it is in the chamber, it adjusts the tension on the reel to keep the tape centered in there. That is a very clever thing. They did the same thing in the ACR 25, although the chambers were much smaller. This works really well, and the only thing that happens is the light bulbs in here burn up, and you have to replace them. And the glass is special, so you can't just go to a hardware store and buy a piece of glass if you break these things. They're coated with something special. There's an electrical coating on them as well. I don't even know what they did. I do have a field bulletin that talks about it, but it's complicated. Another nice feature is the head wheel. On the other machines, there's 3 screws to get the head out. On this one, you push a button in, and there's your head. So if something happens in the middle when you're on the air, you can just pull it out, put a new one in. And I get it in the right place. I need 2 hands for this. Now I did it. I'll have to work with that later. So anyway, that's that. The top of the machine has space. This usually came with a black and white monitor. We put a color monitor in here. Since the machine is the machine will play PAL and CCAM too. It'll play 50 cycle or 60 cycle. And it'll play low band, high band, low band color. It's got all these different modes here. And you can set them, you can put the machine to automatic, let it figure it out, or you can force it to whatever you'd like. It's also a 2-speed machine. Most of the quads were 2-speed. It'll record a 7.5 if you want, which will double your tape time. I'm not sure what else I can tell you about it. When you pull this out, there's all the air system right in front of you, because you do have that vacuum column for the tape tension. So you need to make sure that all these pressures and vacuum are in the right place. Well, let's close that up. Okay. The air system is down here. And that's the vacuum. That's a vacuum pump for those air columns. And this one used to have a compressor for the head, but it was taken out before I got it. And I run it off my house air. So any questions?
On my PV 120, what type of a head design did it have?
Oh, that's a very good question, because it was very interesting. It was a relatively, boy, if I had time, I could show you the machine. It had 2 heads. It had a video head and another one called a sync head. And the sync head was only in contact with the tape for maybe 20% of the time, just enough to make sure that all of the television frame was recorded. The selling point that they had for that machine was, when the video head wears down, and they wore down very fast because it was an alloy head like George mentioned earlier, you could pull the sync head out and swap it with the video head, and you're back in business right away. I thought that was clever. Heads weren't, I remember Sony New York used to be in Long Island City. And I tell you, once every 2 weeks, I used to go over there and get heads. It got to the point where the service manager knew I was coming. He said, "Oh, John, you know where those parts are. Go back and get them and sign them out." That's how Sony was back in the day.
So it's a very rare machine in itself.
Yeah. Again, there were. I should probably qualify this. There were 2 different models. The first one was called a PV 100, and the tape ran at, I think, 5 1/4 inches per second. It had a very special hub to mount, and they didn't make. There was only 2 tapes sold. There was a half hour and a 1 hour, and that was all there was. And this was probably around 1962. In later years, 65, they had this machine called a PV 120, which recorded at a slower speed, but you could put more stuff on the tape. They built that to compete with the Ampex 660B, which was another 2-inch machine with a relatively large drum, which I think it ran at 3X or something like that. And that thing would record on a roll of a large roll of tape. You could get 5 hours of recording on that machine. And they were very popular. They were used in a lot of, you remember what ITFS systems were? Anybody remember that? That was instructional television fixed service. It was a 2.4 gigahertz FM radio.
I had 4 channels of it.
Okay, well then you know what it is. So the ITFS people love that 660. They used them everywhere because they were stable enough to broadcast. This is before.
How many of those machines do you think they manufactured?
Which one, the Ampex or the Sonys?
The Sony PV 120s.
I can tell you, in the East Coast here, I put a bunch of them into Western Electric factories, between 1964 and 1967, probably a dozen of them. And that was probably the biggest customer they had. I don't think very many of those were sold. And they're really hard to find. I have not found, I've been looking for another 120 for 50 years and I haven't found one yet.
Well, maybe if you have something to trade me, we might talk about that.
Yeah, well, I got a building full. Does it work?
It looks very nice. I'll put it that way. I've never tried to operate it. I did put it away and I haven't looked at it in a long time, but I do know where it is in my stuff. But yeah, I need to drag that thing out and bring it to ETF sometime if you go there.
Yeah. Okay. All right, we'll have to talk.
Okay, thank you very much.
Sure.
I have an interesting piece of literature from May of 1973, the Ampex price list.
Oh, yeah.
You could get a VR 1200B in color for $69,950, $70K. ABR1 in color, $110,000. So don't you wish you could get it? At the end, it was a whole bunch more. And that was without any of the accessories, you know, that such
Hey, Chris, did they ever sell an ABR1 monochrome?
I don't know, but they list it as $102,000, $102,000 monochrome. You know, maybe it was sold in some country that didn't have color at that time.
You know, I mean, I'm pretty familiar with the electronics in this machine, and I got to tell you, the color circuitry is so stitched into everything else. I can't imagine how they could do that.
Neither do I, and but it was interesting to look at this. But you know, there's
who was mentioning the MTV stuff before, because I worked on that project.
Merlin Engineering, I thought, did a stereo kit.
No, Merlin was not involved in that. The machines were bought by Andy Citos, and he sent them to Toshiba Ampex. Ampex had a long-standing cross-licensing deal with Toshiba in Japan. So three of those, there were three ACR 25s. They went over to Japan. Toshiba put custom heads in them and custom electronics and sent them back. And Andy put Dolby A on them. And that's how the MTV went on the air.
Okay, I'm totally out to lunch. Typical for me. But interesting, autochroma on an ABR1 was $6,000. Auto tracking was $3,000. So you know, you could spend a lot of money on an ABR1, and that was before you ended up with the price increases due to inflation and all the other stuff.
Well, every one of these machines supposedly was wired for every possible option that they had. This machine's got everything in it except for the editor card, and I think the editor card needed to have this a special control panel here too, which I don't have.
Yeah,
so,
that is a different control. It's the same control panel in an ACR 25.
I've got two of those also. Sorry, I didn't get to show them, but I have I have a 25 and a 25B.
So, so an actual 25 exists now.
Oh, yeah, it's intact. It works.
Ah, nice machine.
I got a TCR. Anybody know where I can get an SP100 for that thing? Nope.
No. Well, if you got a TR70,
I got two of them. No, that's how my TCR was set up. I have a TR70C with the master kit in it. And when I connect it up, the only thing is you need 6 30-amp circuits to turn the whole mess on.
Yeah. Well, the time I worked with an ACR 25 at the station, we had dropout school, and do you have alignment tape? And they were down to like a quarter mil was all that was left on all 4 heads on the 2 machines. We need some heads. Oops. Nobody ever checked that stuff. But it's interesting. An NTSC PAL AVR CCAM one was 117 grand for an AVR one.
Really?
Yeah. And this is in 1973.
Yeah.
Yeah, don't.
Yeah, this particular machine, George knows the history of this too. This machine was at PBS in Washington. And it was in, there was a structural building fire around 1986, as I recall. I'm not sure if George was 84, 86, sometime in there. So all of these machines, they had a pile of these, and they had about 25 VPR2s, and all these were pulled out. And the VPR2s were cleaned up and put back into service. The AVR1s disappeared because it was the end of the line for quad. So there were 4 of these machines which meandered around the East Coast for a while and wound up in a warehouse way out in Long Island. And through the good graces of Paul Beck up in Boston, he got a truck and went out and picked these things up and brought them back here. And one of them fell off the truck in my loading dock, which is this one.
And that must have made a big dent in the concrete.
Paul's used to driving around in big trucks. He just has a knack for that.
We had 5 AVR2s that had been in a fire in Grand Rapids at a Bible place, and we kept 2 and sold 3 that paid for everything. We had to replace basically everything on the transport. The biggest problem was some of the ICs were damaged by heat. It took a bit. Biggest problem I had with the AVR2s was the time-based corrector would vary because it did a 4-bit and then another 4-bit, which was weird, rather than do it straight. And the easiest way I found to get that thing to work nice, stick a ramp in, blow it up as high as you could, and get all the steps out of the ramp by adjusting the 2 pots on the A and B cards, and it would make beautiful pictures after that.
Yeah, somebody told me that, well, you know, that the digital time-based corrector stuff started with their helical scan group in Elk Grove Village. It didn't come out of Redwood City. And they built this thing called a TBC 800. Was it 800?
CVS, the 504 was like 6-bit or something like that.
This was a big bathtub shaped thing, and you put the VPR 7900 on top of it.
Oh yeah,
you remember that? And the 7900 was the first 1-inch machine with H-lock. So if everything was right and you know it was the right phase of the moon, that machine after 8 or 9 seconds would actually H-lock, and then the TBC would work because it didn't have that big of a window. And I understand that some of that technology came out of the AVR1 project. I think
the VPR 7900, and I got the price on that sucker here right in front of me.
Yeah, there's one. I just went past one over here in the shop, which actually is in pretty good shape. Came out of Bell Labs. I installed it for them in, I guess, 78, something like that, maybe 74. And
yeah, you were talking 34,000 list.
Yeah.
And so you can buy a 1200 for 70,000. And the first time I saw the 7900 with a time-based corrector, they took an Amtech and a ColorTech and made it work.
Yeah. Well, the only thing about those machines was that the broadcast engineers that I knew were used to dealing with these big iron machines. And when they got that 7900 in, or 7800 before it,
a dog.
It just, they couldn't deal with it because it needed interchange adjustments all the time, because it was a very large drum. It recorded a complete field on one pass of the head. And the entrance and exit guides were very critical. I mean, you breathe on them and they would throw the machine out of interchange. And then trying to get tapes to play back from another machine was a nightmare, which was it's been a chronic problem of 1-inch machines since day one. In fact, some of the early machines had caveats in their sales literature that said, at this time, we cannot guarantee that tapes made on any machine will play back on any other. I remember reading that in the 60s and going, gee, this is not a good thing. And then in New York here, we had a guy at J.C. Penney who decided to put in a whole network of Sony CV machines, the 1/2-inch. And it cost him his job because, of course, they wouldn't play the tapes that came out of New York.
Well, the 7000, all that series was made originally in the Elk Grove Village, and and it was a totally different engineering team, and the guys out in Redwood City weren't consulted together.
No, it's very obvious when you look at those machines. I've got a 7000, a 7500, 7800. I got a couple of 7950s that I'd love to get out of a trailer too. Like I said, I got to talk to Dave about maybe doing a 1-inch seminar, because that's also a very interesting bit of experience, is how those machines came. I've got a 1961 Norelco machine here, which is all vacuum tube, and it works pretty good. In fact, Andy Warhol used it for his home movies. The only problem with it is, again, like anything else in that era, there's no interchange. So we had some Andy Warhol people show up a few years ago, and I tried to adjust the drum and the exit and entrance guides so I could play the tape, and I couldn't get it. I probably spent a week working on that, and of course they wouldn't leave the tapes. So that was the end of that project.
Well, interesting, the IVC came out about that time, and we evaluated and the Ampex machine. I love the signal system on that, and I love the transport on the IVC. If we could have married the two together, it probably would have worked nice.
Yep.
I'm sorry, we're having this private conversation everybody's listening to.
Yeah, any questions about these squad machines?
Yeah.
Hi, Wayne.
Hi. Do you know what machines RCA used at the World's Fair? Because they had this 10-second delay by recording on one machine and 150 inches of tape later of playback.
A lot of people did that. I did it at WOR with a pair of VR 2000s. I think they were about 8 feet apart, and we put some rollers in the middle. And the nice thing was that, those quad machines don't really have a big problem with back tension. So we could have one VR 2000 recording video and another one playing it back. And we did that for, what was that? It wasn't Howard Stern. It was the guy before him. Morton Downey Jr. had a TV show on the air, and he was known for being a little rough sometimes. So the standards and practices people at WR insisted that we delay his video before it went on the air. So that was done with a pair of VR 2000s.
Yeah, we had a pair of 1200s with a bunch of roller arms in between.
Yeah, same thing. Yeah,
homemade.
Yep.
Nowadays, nothing's on time. It's all delayed anyway.
Oh yeah. Yeah, and throw in streaming and it's 30 seconds delayed.
Audio and video separately.
Yeah.
George, anything that you glossed over quickly that you might want to go back and touch on?
No, not too much. On that velocity correct, they did sell a very expensive option on all the machines to correct that velocity error. It was about at least $10,000 on an Ampex machine. And when they got to those digital machines, they all, like the TBC 800 you're mentioning, John, and all those, they also have digital velocity error correctors in them to correct for that. You really can't tune it out with the guide. It was something that was inherent. So having a VEC on a machine, that RCA made a module called this KVEC, which was chroma amplitude and velocity error corrector. It was built by some other division of RCA, but I'll tell you what, it worked like a champ. One other thing I might add on those time-based correctors you mentioned, John, for the TBC and Chris for the AVR2, I think Tom Sprague's got the backstory on it, but they had two teams working on that. They had one team working on a switch delay line time-based corrector, kind of like what's in the AVR1, and they had another team working on a digital time-based corrector, which is wound up in the AVR2. And Tom's got one of the analog ones hooked up to, of all things, a TR22 up there at MBT. And so it will take the output of the machine and time-based correct it and do all that stuff. But it's I guess it's a prototype or something, and I don't know where he got it, but it's an analog version of the box, and it looks like the box that goes below VPR2 for the time-based corrector, but it's an analog switch delay line box rather than a digital box.
Kind of like the AVR1 kind of.
Yeah, apparently they had that idea and they made a smaller one, but then the other team was working on the digital TBC and they packaged that, and there was a machine called a TBC 800 and there was another one I think called a TBC 1, and I don't know the differences in them, but at one time Maryland,
just the A to D and D to A's were different, George. I remember that. I've got a couple of each of those, and then I think in the TBC 2 they TRW had come out with that big chip, and that replaced two boards in the TBC. They pulled two boards out of it and replaced it with that one chip.
That makes sense. I put one of those TBCs, digital TBCs, into an Allen, and that replaced the Amtech, Colortech, Procamp, dropout compensator, everything. And it made it looked like a VPR2 then. I mean, it really made nice pictures out of it. And then you just had to pick up the RF for the dropout compensator in it.
Interestingly, Ampex came out with a velocity error compensator, Velcomp, the $11,000 price, as you mentioned. And then RCA came out with the same thing. And they figured out, hey, I got the same thing we're addressing. Let's do the chroma as part of the same package. And that's why it's called KVAC.
Right.
And they came out second with that. I talked to one conversation I had with Charlie Anderson. I said, I always like the look of the analog TBCs. You don't see the digitizing. He says it's a cost thing, and you got so much better range, etc. And so that's why they dropped. That was one of the things the reasons why they dropped the analog and went totally digital.
It was interesting in the TR600 that John showed you a while ago from RCA, their last quad. They tried to build a digital TBC for that machine, and apparently it didn't work well. So they took it out and went back to analog time-based correction, just like the earlier RCA machines, which was fine.
Yeah, George, I heard that a bunch of Drexel grad students designed that 600 electronics.
I don't know. They worked.
Well,
Well, as a Drexel grad, I have a question. Hi, George.
Hi.
The question I had that you haven't mentioned, what was the rating of the number of tape passes that you could get out of a tape?
Oh, I don't think there was a big problem with that. I mean, if you could probably get 50 to 100 passes on it.
Or more.
Yeah. Chris, you probably know.
I don't. I know on the ACR 25s, we'd be playing the same commercial and promos all day long, and you keep recycling those, and they'd be at hundreds of passes. I was doing primarily editing, and so it was all computer, and you'd be making all sorts of passes. I never had a problem with it wearing out. Now, there were some issues with some tapes that the binder wasn't done well, and you get shedding, and we threw that back to the manufacturer real quick.
It depends on the tape brand, and it depends on how they're treated and where they're stored and things like that. I would say you could probably, on a good tape, maybe get a couple of hundred passes anyway, or something like that. But MBT's got a whole lot of low band color tapes of the Joan Rivers show from the 1960s. And the story I heard on that was that Joan Rivers used to joke about her husband being tight, and he really was. They told me he would go out to the dumpster at NBC and pull tapes that they had thrown away in the dumpster and take it back in and say, here's what you're going to record the show on for syndication. And tape reels were pretty expensive in those days. But if you didn't have a dropout compensator, I'll tell you what, you would get a snowstorm on some of these tapes you'd put up. So once they came out with dropout compensators, you could probably live with the tapes running longer, and everybody had DOCs, into the 70s. But earlier than that, in the 60s, not everybody had a DOC. So it didn't look good if the tape was worn out.
Well, that's what I was wondering, because the distortion of the tape when the head goes through it.
You know what? It's amazing that after, like Chris said, on the ACRs and the TCR, those carts got used all the time, over and over and over. And unless you damaged one, pretty much you never had to touch them. And those things would, you got 30 seconds to a 1 minute or spot on those carts. And, you could play those things 100 times in a week, maybe more. Never had a problem. And I was just going to say what George mentioned earlier about, the head tips penetrating into the tape at 14,000 RPM. You would think it would wreck the tape, but I guess you got to really hand it to 3M. They really figured out how to do that. I mean, it was quite the chemistry of videotape is half of this. These electronics developments are wonderful, but if it wasn't for those guys in Minneapolis that figured out how to make that tape.
And if you'll notice on the shoe at the top, there is a little bit where the curves, and then it has a slight curve up to vertical, and that's where the head enters. So it isn't hitting the edge of the tape; it actually goes in. And because the audio track is at the top, you don't. It doesn't matter if you are intimate contact immediately on the head. You got a couple mils to get down to where the actual tracks are.
Yeah.
It's just amazing technology.
Yeah, I don't know anything about the chemistry of making that tape, but boy, it just seemed to get better and better. But every once in a while, you get a stinker. I had to record Governor Rockefeller once in the Waldorf Astoria back years ago, and I had to do it on 1-inch machine. So I had a Sony EV, I had an IVC 820, and I had an Ampex 7500. And I figured, okay, I can't go wrong. I'm sure I'm going to get this thing, because he was going to talk for an hour. So I had this all set up, all this tape racked up. Well, the Ampex clogged in 15 minutes. The Sony clogged in 20, and the IVC clogged about 25. So I blew that whole recording, and I forget who it was for, but it was somebody big deal. And the only thing that was common about that whole episode was the tape was Memorex Chroma 80. And to this day, when I see a roll of that stuff, my attitude is throw it in the garbage, because I never saw a roll of that stuff that ever worked. And I mean, maybe the 2-inch was better, but boy, that 1-inch stuff was horrible.
They had their issues with 2-inch as well.
Did they? Yeah.
Interesting. We once had a guy that recorded this major speech by CEO of an automotive company, and he did it as insert edit on a blank tape. No control track. Oh, we salvaged that. But it took us all night to figure out how to do it, make up some breadboard stuff. Interestingly, the tape stocks were different. Fuji had a very stiff back. 3M didn't have as stiff a back. And then you had the problem that the different way the pinch rollers are set up on the machines. If you look at a ABR 2, a 1200 or whatever, 1000, it comes in and there's a thing at the top and bottom and it holds the pinch roll. It has to come in perfectly parallel to the capstan. if it comes in where it hits the top or the bottom first, it skews the tape and it gets damaged by the next guy down, which is the audio stacks. RCA has the other problem. There's a self-centering one, and it also does strange things to it. So you had to be real careful. We had a lot of tape damage on syndicated shows that were sending out. And we didn't like that.
Yeah. Well, I don't know how,
These
I don't know how,
life,
sorry, go ahead, Wayne.
yeah, these lifetime figures for the heads and the tape is what interested me about the World's Fair, because they were running that see yourself demo all day long for 6 months. And so I was wondering how often they had to replace heads.
Well, you know, that was 64, 65. I don't know if they had those Alphacon 2 heads at that point. I'm not sure if they did, but the later RCA heads lasted a long time. I mean, I got some those TR60s I have 4 of them here, and I haven't touched the heads. I mean, since I've had them, they just run and run and run.
Spin Physics did the first 1,000-hour guarantee, I think, didn't they?
Yeah, I think maybe you're right. Yeah.
But we were getting 600 to 1,000 hours on Mark 10s and Mark 15s. If we were down at the bottom, we were thinking we've got something wrong. But we also had no smoking allowed in the area, clean room, tried to keep it clean, and the machines were kept clean. But it was anything less than 600. It was like, oh, we got a problem.
Yeah.
And at that time, I think it was $1,200 to refurbish, so $2 an hour.
It's very expensive now. With Tony Cortez shutting down his operation in Colorado Springs, there's only one guy left, I think, out in California who's doing that. And I don't know what he's charging, but I bet he took advantage of the fact that he's, let's see. Girl's got a message up here, a head tech. How much? $7,000 for a rebuild? Wow. Wow. Tony used to charge me $1,500 for the Mark 15s.
Well, it's gone up, and you could buy a brand new head for like $3,750 for when you bought the machine, and it was just keep trading them in.
Yeah.
Those burnout machines, I sent one to Ampex, and I sent one to the guys out in Video Magnetics or whatever, somebody out in California, and Ampex comes back. We aren't going to do anything with it. Well, send it back to me. I got somebody that will do it. Well, we took it all apart. They sent me a Mark 15.
Yeah. Yeah.
Great machines.
Yeah, it's a lot of fun. It's all over now.
When you think they lasted 20 years in manufacture, and then you look at some of the other machines, all those digital machines like D1, D2, D3, D5, they didn't last that long.
Well, I've got a pile of D5 HD machines, and other than some capacitor issues, they've been very, very reliable. I've not had any trouble with them at all. And I've had them
manufacturing.
I've had them for 20 years, and I've got 3700s now, but the original machine, the 2000 and the 2700, the only thing that goes wrong with those things is a little electrolytics. They tend to short out or open, or they just go bad. I don't understand why Panasonic never learned anything about that, because the machine is inherently is a great format. Not good. I mean, I've got Sony machines that are from 1963 that never had a capacitor changed. I don't know. Same thing with these quads. I mean, I don't think George, I don't think I've ever replaced a cap in an RCA power supply, but I have replaced them in the video output modules. Those things have gone bad. But when you did that machine up in Boston for up in Rhode Island, did you have a lot of capacitor issues with that TRT?
Oh, with the TRT, with the TRT1, we started out by replacing every electrolytic can in the machine. It was about $3,000 worth of cans from Hayseed Hamfex. We just didn't want to mess with them because they were bad. But we didn't touch, and then on the WP16 power supplies, we replaced all the big electrolytics in those WP16s, and I rebuilt the 150 minus 150 supply and replace those caps. But any big electrolytics we changed because we've literally had them explode in the machines. And in fact, we had one just recently. Jay turned the machine on to demo to somebody, and the 24-volt supply, you know, those for the relays didn't come up, and we thought, what could have possibly gone wrong with that? Well, that thing's got a constant voltage transformer in it with a resonating cap on it, and the resonating cap had shorted on the transformer. It's a big oil-filled cap, so we put a motor capacitor in there, and bang, it comes right up. But we did not touch any of the other capacitors in the machine. All the regular values that were not electrolytics we left alone. And when I went through the machine, I only found one of those caps. There was a 0.1 600 volt or something like that sprig in the one of the servos that was dead shorted, and that was the only one I found. All the rest of them we left alone, and they're fine. But the electrolytics, they're bad, and rather than keep troubleshooting weird problems, we just swapped them out.
Yeah. The only capacitor problems I had with this AVR1 were in the sub base for the head. There's a bunch of tantalums in there, and plus or minus 12 volt buses, and they were all shorted, every one of them.
I haven't in the later machines, like I did the TR4 high band and those, and the electrolytics, those little Mallory silver caps that the RCA machines are just full of. I've maybe found one, or I think I had one of them short in one of the TR70s, but most of those are holding up just fine, and that's really good for them.
Yeah.
I think on a couple of the AVR2 boards, we had some capacitors go bad on the main incoming power line to each of the boards.
I think Tom changed a slew of caps in the AVR2 at MBT. I don't know the story on.
The audio board tantalum's short, and when they short, they burn up. There's a series resistor, a small one, 2 ohms, 5 ohms, something like that, off the machine bus. And when those capacitors short, that resistors explodes, and usually it sets the board on fire. No, I had that happen over at ABC, and we wound up having to actually find another board because it just charred it, couldn't fix it. So, you just got to be aware, watch for smoke all the time.
The odor resistance.
Yep.
You're bringing back memories.
Yeah, sorry about that. Hey, Chris, are you the guy with the RA 4000 drawings or books?
Yes.
I got to talk to you about that because I have an RA 4000.
You have one?
Yes, I do.
And you got AVR ones?
Yes, I do, right behind me.
How many AVR ones?
Oh, I just have one of them. But the 4000, I think, will work with AVR 3s.
Could be. I don't know. AVR 2s, there was a thing that went on the back of it so that you could interrupt the cables between the transport and the electronics to take over control. I've got the complete 4000 manual.
Yeah, this one I have came from Belo, came from originally WFAA in Dallas.
Frank Davis. He's the one that I had problems with it because the AVR2s are so damn fast on lockup that the RA 4000 looks for a coincidence between the time code and the time code counter is counting down. We use 10-second rolls because I think it was because of the you needed to get a little bit better. You use 3 seconds instead of 1. And boost was still on. And guess what would happen? It would slip. Couldn't get metric. And it was, no, it's in the machine. It's no, so about 3 in the morning, we figured it out. And he goes, oh, sometimes you have somebody grab you by your ears and pull your head out of your know what.
Yeah, I just want to see if I can fire it up and make it do something. I have no idea if it works.
Easy to fire up. Is it all in the console?
Yeah.
We had a 5 machine one. And I'll tell you, we were the only house that could do 5 machine edits. And we had a situation. But
I don't want to revisit editing. I had 3 TR-70s at an ad agency in New York that we made work with a Datatron tempo, and that was a nightmare.
You got my sympathy.
Oh, it was just the voltage interfaces to the RCA were difficult because of that 70 volt business, and the Datatron at the time they had never done one before, and they built me these interface boards, and they didn't work. And finally, I guess it was Tom Belford, who was their tech at the time, came up here and we worked on it. It took about 2 weeks before we figured out how to make it work. We built all kinds of voltage translators and all kinds of stuff to make it talk to the machines. But it worked for a while, worked pretty good.
Okay, so let me ask questions here. The AVR 3s, what do they have on the back for connectors? Do they have one that's like a different remote than the remote?
I'd have to go back and look. I got 2 of those. The one I showed you out in the lobby, and then there's one back here. I don't know. I'll have to, I've never controlled them. No.
Okay, well, it's just asking the question because the cable was a big multi-pin that went off to the interface box, and then it would translate from that. Also, you can make the thing do color frame, even though it's not built in, because it was designed for both PAL and NTSC. Take horizontal drive, divide by 2, feed it into the 7.8 kilohertz, stick it on the back of it, and away you go. And then you've got the ability to also do previews with a switcher inside the RA 4000. So you're looking for a book.
Yep.
Okay. Let's talk a little bit about how we can do this. Because I got the book. What am I going to do with it? I may have a 4000 interface manual too. And so we can see what we can do there for you.
Okay.
Yeah, my email chill315@AOL.
Okay.
George got my Squeeze Zoom book. That was a piece of junk.
Anybody got one?
Squeeze Zoom. If they do, shoot them. They're out of their misery. And where are you located in New Jersey, John?
I'm in Morris County. I'm between Morristown and Boonton. Route 80 goes right through here.
What?
Route 80.
I-80?
Yep, I can go from here to San Francisco.
Why would you want to go to San Francisco these days? It's gone down the tubes.
If I wanted to, well, you don't want to be here this week. It's 90 degrees outside still.
I don't have air conditioning where I live.
Oh, well, do you need it?
Only on a couple days a year.
Oh, well, we've had
I live in the Detroit area.
Oh, yes. It's been pretty hot here on the East Coast.
Yeah. So anyway, we can talk offline do this offline and figures out what to do, because it may not be worth it if you don't have the right cables or can't make them up.
Well,
Yeah.
I can make cables. It just, I want to make sure whatever boards or parts need to be in the RA, that they're there. I don't know.
As long as all the cards are in there, you should be in good shape. There's 2 frames. The bottom one has 3 sets of cards for the 3 machines, and top one is all the logic and all the other stuff. And the only other problem you'll find you have is the people pound the switches through the panel. It was the fastest editor that I ever watched go. It was faster than a CMX. We did 30-second spots. I could crank them up.
Yeah.
I cranked out 15, 20 of them in an hour.
Wow.
Well, 5 machines, 1 machine's record. Just keep loading, guys. There, we're doing cores and inserts. Before the client walks in, you lay down all the bars and tone for minute spots. Just 1 minute, 1 minute, 1 minute, add. But you have to know how to do it to make it work, so that because your durations, you can then to do match frames. It's a little tough if you don't do it the right way. Okay.
All right, Dave.
Let's see. I haven't got anything else at this point. I'll see if I can find you're close to New York City then.
Yes. I'm about 25 miles west of New York.
I never liked going there. That's my. Okay. I see, I'm looking at my map. Yeah. Take the train, take an Amtrak train. Anyway, all righty, we'll see what we can do for you on that. I'll see what I've got. It shouldn't be too much of a problem, but I don't know if it can interface or not. You'll have to figure out. I know it was direct plug into the AVR1 on the back. Oh, Charlene is on. IBM, where the heck are you?
Look at this. You got 2 AVR1s in one place at one time. Amazing.
All right, on that note, maybe we'll roll up the sidewalks here, but thank you to both of you. This was absolutely fabulous. Real nice look behind the curtain there.
Quick question.
Go ahead.
I had a quick question. I wonder if I joined late, and I wonder if I saw John in his collection see a VR1000 Ampex.
Yeah. Yeah, I showed one of them earlier. I'm not sure. If you want me, I can roll over there again and take a look. You want to see it?
No, don't bother that. But
I got stuff set up on
my
a
boss
cart.
was
I
Ray
gotta
Dolby
roll
for
over.
35 years, and so it was interesting to see that.
Yeah, it's a 1000C, the model that I have.
We'll have
That's
the
amazing.
recording. The recording will be on the Early Television YouTube channel, so you can go back and catch it there, or as many times as you want.
Okay, I'll go back and check. My boss was Ray Dolby for 35 years, so it was really interesting to know that you have a VR1000.
Yeah, there's a couple of them around.
The one at MBT in Rhode Island is functional. It's a color machine with intersync, and it's a VR1000C.
Oh, the B one?
B, was it a B? Okay.
Yeah,
But anyway, it's color. It's got the
Yeah.
Amtech and color tech on it, and
That's
the
a
intersync.
long story with that machine. Tom, we were bidding together on an auction in New York. And Tom was interested in a Dumont scanner. And that thing showed up on the auction. And I said, okay. Well, behind it and part of the same auction were 2 racks of VR1000B electronics. So that's how Tom got that.
Let me go grab my 4,000 book and I'll be right back. Okay? I'll see what I got for you. Then we can call quits.
Okay. Why won't that head go back? What did I do here? You know, one thing we didn't talk about in terms of maintenance on these guys was what you need to have to work on these machines. Every one of these machines came with a library of manuals. The AVR ones, there's at least 5 or 6 books, pretty big, thick 3-ring binders. And then there's a whole bunch of supplemental material on the options and on the FEBs, the field engineering bulletins. Plus, you need to have all the extender boards. And this machine, the AVR one, there's got to be about 8 extenders, and every one's different. Let me see if I've got one up here. Yeah. This is one of them. And the connector's offset on the end. And this is only good for one small area of the machine. There's a whole pile of these things. If any collector that wants to get into this business needs to make sure that he's got all the pieces. Otherwise, he's got a ghost machine. He's never going to get anywhere. It's very important. And then, of course, the other thing that's nice is if you've been to school on this, or you know somebody who has, or you know a retired television station engineer, these machines take quite a while to get used to and really dig into them, because if you don't do things in the right order, you're likely to get yourself really bollocksed up, and you'll cause more damage than you will fix. So there's a certain sequence doing things on these machines, and you have to know what that is. And some of the stuff is it's not intuitive, and it's something that you only learn if you go to the manufacturer's class. And last time I checked, Ampex was no longer running service classes on VTRs. Oh, too bad.
Okay, well, I've got the book here. By the way, this it's got the 2000 1200 bits, and for the interfaces, I do have an interface for 1200. The schematics are 80 some odd pages, and the LMs are 145, 150, and
yeah,
it's not hard. There's a power supply up in the top, and then down below, it's pretty straightforward. I'm just amazed that there's no computer in it. It's all hardwire logic. So somebody had to do one hell of a job of figuring all that out to make it work.
Wow.
You know what I'm saying? Now, the other thing is, the book is for the 80-bit thing. There was a earlier version that I don't know if they ever sold it or not. That was before timecode was set up as 80 bits. And so that's why it's called the 80-bit version.
Yeah. Yeah, also known as SMPTE.
Yep. But the only thing you did with a 1200 was you had to put a preamp behind the audio stack so you could get the
wideband in shuttle. Yeah.
Yep, and then you had a bunch of cables that you stuck in between the control panel to the other thing. So there were different little harness things that were just extenders. Had a plug in a socket on it, and so you put those in place. It was pretty straightforward.
Yeah, the AVR3s have a wideband output off the Q channel, and they reproduce timecode just great in shuttle, no problem.
Okay, the RA4000. It's looks like it just has a bunch of commands that go into it, and then another one's for the editor. And it's pretty straightforward.
Yeah, I just want to light the thing up and see if I can work.
Well, if all I would say to you is just plug it in and turn it on. If there's no machines on it, it doesn't care. It will just light up if it's the case. And but by the way, that sucker was expensive at one point. And let's see, I got the price list here. Was I don't know what idea it was. RA4000. Basic was 21K. It was 30,000 for 3, and we did a 5 thing, so we added another 41.9.
Wow.
And then you had to add the interface for 212 for the 1200s. And with the AVR ones, you just needed a cable. So it was pretty straightforward. Anyway, I'm done, unless somebody's got something else. It's getting close to bedtime. What else can we do to ruin your day?
Yeah. Yeah, we shoot up another Saturday.
Hey, it is what it is. I can't be out on the lake, so yeah. All righty. I think I'm done. Anybody? George, have you got anything to say before? You're always good or something.
Oh, great. Thanks for everybody. Thanks to everybody. And thanks, John, for doing the great demo.
Oh, did I mention that it was Keith Reynolds who was the modular products guy to you?
Where do I know that name from? Was he
Yeah,
IBC?
I know Keith Reynolds. From
Yeah.
Grass Valley.
Grass, yeah.
And he was with IBC before that.
Yep, that's where I knew him.
I used to work at Grass Valley, as did George. And that's gone. It's a shadow of itself. I understand there's nothing left out in California for it. All righty. I think I'm going to call it quits. Leave you guys. Have fun. It's always good to see George. And a very good, interesting discussion about 2-inch tape, which I loved.
Well, I'll have to get my PV 120 out and go over that thing. The only problem is I don't have any tapes for it. I think that's the main reason I never investigated it more thoroughly.
Yeah, you're not going to find any either. Boy.
Do you have any?
I have one tape.
Oh.
And I don't know what's on it because it's a 120 tape and I have a 100.
Well, I'll have to drag it out then and see what I've got there. But anyway, was it a helical scan or was it a straight?
Oh no, it's helical. And the machine's got, I think, about 8 vacuum tubes in it, which is another interesting thing. The
Oh.
motor, yeah, the motor drive amplifier are tetrodes, and there's some 60 J8s in there for preamps. There's all kinds of cool stuff in that machine.
Do you have any manuals on it or anything?
Oh, I got all the books.
Oh,
That's why I just want, like I said, you're the first guy in 50 years that I've ever talked to who had one of these things.
you're not breaking any new ground here. I've got a lot of things that people haven't seen in 50 years. But anyway, I'll drag that thing out, and if you've got something more interesting, something, maybe we can do some trading there.
Yep, let me know what you're looking for. Yeah.
Okay. Well, thank you so much. It's very interesting. I finally found somebody that really, they can explain some things to me there.
I used to fix those things. But, I'll tell you, it's a long time ago now.
I've got two Ampex, 2 quad machines. I think they're the 1200s, maybe.
Yeah, that was pretty common.
I've got 2 of those. One's both record and playback. The other one's just playback only. But I might be interested in trading one of those for something interesting. I don't need 2 of them. But
Yeah,
anyway,
I have a pair of 2000s, but I don't have a 1200. I'm not sure I need it.
Well, find something there. But anyway, what's his name wants me to do a thing on part of my collection here on this very channel here, and I've just got it scattered in 4 buildings, and it's difficult. So I'm gonna have to do some videotaping here or something.
Yeah, I've got 2 trailers out in the back here, and I got another one out in the front parking lot, and they're just full of quads.
Oh,
and
well, that's interesting.
And cart machines.
And I thought I had a lot of stuff.
No,
Took me 4 buildings to do all of this.
We had 9 trailers full of stuff, and one of my sons who works for me here made me throw a lot of it out. So we're thinned out, but I'm not as thin as I should be.
Where are you?
Pardon me?
Where are you located?
I'm right off Route 80 and 287 in northern New Jersey.
I used to live up in New Jersey up there. I was at Fort Monmouth, New Jersey.
Oh, that's south of me. It's quite a way south. Yeah.
And I was a radar instructor up there.
Oh, okay.
So anyway, I know New Jersey pretty well up there, and I miss those days.
It's on the south side of the bridge.
Yeah. I used to hang out there in Seabright and Asbury Park and all of that, and I miss those days. Although I hate New Jersey and it's a police state, but I still miss it, though. I remember the days I used to have up there, driving into New York City and doing stuff up there. But anyway, we'll talk soon and all of that. I'll dig this machine out there and see what I've got. And anyway, thank you so much. That was an interesting chat that you did.